Okay, how are we all doing? So we're up to Chapter 8 of Routing and Switching Essentials, which is DHCP, or Dynamic Host Configuration Protocol. So we're going to look how to implement DHCP for IP version 4, and so we're going to have it so it can operate across multiple LANs. And so we're going to set up a router as both a DHCP server and a DHCP client, and we'll look at troubleshooting DHCP and IPv4. We're also going to do DHCP for IPv6, again across multiple LANs, and we'll talk about how it operates, because it does operate differently to IPv4, because IPv6 is normally stateless, or easily stateless, and of course we'll look at both stateless and stateful DHCP. And we'll of course look at troubleshooting that as well. So IPv4 DHCP. So DHCP assigns IPv4 addresses and other network configuration dynamically. A dedicated DHCP v4 server is scalable and relatively easy to manage. A Cisco router can be configured to do that on a smaller network. And so of course basically what happens is when a client boots, it sends out a DHCP discover message. It says, is there a DHCP server out there? And of course one will, if there is one, it will reply. In more formal terms, basically, as I said, they send a discover message, which is broadcast, saying, hey, I need a DHCP server, please. And all DHCP servers that see that request will reply. The host will choose one that it will actually then communicate with, typically the fastest one. And so it says, I accept that IP address offer with a DHCP request, and then the server will acknowledge it, saying that yes, all good, that address is yours. Okay, so and so basically ports 67 and 68 are used for DHCP. So the client uses port 68 and the server uses port 67, and so and of course it's UDP, user datagram protocol, because there's not that many packets, and so basically from there you have your header information, hardware address, and then later on then you have client IP address, your IP address, server IP address, and so on, extra information, whatever it might be. So basically when the client boots, it sends out that DHCP discover message, and so this is what it looks like. So now of course the destination MAC address is all ones, so all F's of course displayed to us. It has, of course, the host knows its own MAC address, and so it will have its own MAC address there. The IP source of course is all zeros because it doesn't know its address yet, and it also has the destination IP address of all ones again, because it doesn't know who the DHCP server is. So of course the destination port is 67, and basically there's a whole pile of fields there that are blank. And so then when the server replies with the offer, it will then of course fill in some of those address details. And so and of course it will know the destination MAC address from the client. It knows its own MAC address, and of course it knows its own IP address, and that's the IP address that's offered to the client. And so from there, the client can then either accept or ignore that offer, and away it will roll. So how do we configure it on a Cisco router? And so basically we create a pool, and we have to give that pool a name. So IP DHCP pool, and then give it a name. So Fred, Mary, LAN pool 1. Probably better than Fred or Mary. And so from there you need to specify a network. Now this is something that a lot of people leave out, is they do all this other stuff, the settings they think of, but that pool actually has to know what address range it has. If you don't do that, it will not work. So we're looking at a 24-bit mask for 192.168.10.0, and so we then of course have a default router setting, which of course is the router itself. We have DNS server setting, we have a domain name setting, and you can actually put in other options as well. And so basically, pretty much any option that you can see on a Microsoft server, DHCP server, you can actually do with this, but you need to know the option number and things like that, but you can do it. And so one thing I've missed is excluded addresses. And so basically, we've excluded the range from 10.1 through to 10.9. So of course the router's got 10.1, there's obviously some other ones, and we've also excluded the last address, which is 254. And so of course they will be removed from the pool, being not available. So as you can see, they're done in global config mode, while the rest of this is done in DHCP config mode. But anyway, now you can do show running config to verify that it's working. There is also show IP DHCP binding, which shows you what MAC address is using which IP address as well. Or you can do show IP DHCP server statistics. So of course, another thing you would do is try it out with a host and make sure it gets the right details. That's always useful as well. Now, DHCP relay. Now, basically, as we said before, DHCP discover messages are sent as broadcast messages. And of course, routers don't forward broadcasts. But what you can do is actually configure the router to, when it sees a DHCP broadcast, it will actually convert it into a unicast and send it to the DHCP server. So in this case, we've got one on this subnet here. And so, of course, this DHCP server would need to have more than one pool, one for its own subnet typically, and then also it would have one for other subnets that it's servicing. And so what the router does, it doesn't just forward it, it also fills in the gateway IP address in that header information. And so that allows the DHCP server to know which subnet we're talking about, so it then knows which pool to use. And so that's DHCP relay. So it's a very good plan, and it saves you from having to have a DHCP server on every subnet. So you can have one DHCP server with multiple pools, and all the routers forward those requests to your server. Works quite neatly. Okay, so I didn't actually look at the command, did I? So it's actually, you go into the interface, and so here it's G00. You go in there and you do IP helper address, and you put in the IP address of the DHCP server. And that will then, of course, that will be the destination that it translates those broadcasts into a unicast for. Okay, so you can also have a router as a DHCP client. So typically that would be from your ISP. And so, of course, if you've got a small office, home office setup that you need to put in, basically it's IP address DHCP. Turn it on, and so it will actually send out a request, much the same as any other host. Pardon me. Now, wireless routers, of course, can be DHCP clients as well, and of course, wireless routers also can be DHCP servers, and so that's, you know, if it's your network router, that's often what this case will be. So it'll be a bit from both worlds. So it'll get its external configuration from the ISP, and of course it will look after the internal configuration of all the hosts connecting to it. Now, how do we troubleshoot these things? And so you can have IP DHCP conflicts, and so that can be a problem. Now, not all DHCP servers do it, but last I heard, the Cisco DHCP server, before it actually gives out an IP address, it will actually ping that address to make sure that no one else is using it. And so obviously it's tried to do that. So it's IP detection method detection time, and so it's actually pinged that address and found a conflict. It's also done that with another one with a gratuitous ARP. And so, of course, that's one problem you can have, but of course DHCP normally decreases our problem with address conflicts. But anyway, someone might have grabbed used a static address that was actually part of your DHCP pool. And so, of course, physical connectivity, if your host can't talk to a DHCP server, it's not going to get a DHCP request out and in and so forth. And so how would you test that? You might actually just set a static IPv4 address that works and then try connectivity there. And so if it's not working, that's when you might look at maybe switch configuration is wrong. You might have a wrong VLAN configured or whatever it might be. And so, of course, you might try it on other ports on the same subnet and or same VLAN and the like, just to try these things out. Okay. So basically, to verify DHCP relay, of course, you would just look at, you can do show running config and that IP helper command will be in there. All right, so how do we debug it? You can actually debug IP packet 100, and so we've actually got an access list here matching those port numbers. That's an extended access list, but that's not the way I've done it, I've got to admit. Debug IP DHCP server events seems like a good plan to me, and so that will tell you when it's received request or discover messages, and it'll also do things like for expired leases as well. Okay, so DHCP for IPv6. Now, IPv6, of course, comes with stateless address auto configuration, or SLAAC. And so basically you can, that's one way you can get addresses for a host. And so of course they contact their router with a router solicitation message, and the router will reply back, hey, here's your network and prefix. And the node will figure out its own IPv6 address, or at least the host section of it. And so that does work nicely. But you can sort of have a couple of options that include a DHCP server. Now, see, the downside with stateless, plain without nothing else, is you don't get a DNS server at the very minimum, or if you need other options, they're not going to happen in a stateless setup either. So DHCP certainly does have a use, but you can sort of decrease its use. Now, of course, a router must have IPv6 unicast routing on for it to work. And then from there, the PC1 sends its router solicitation message to all routers and multicast address. And then any routers that are listening to that multicast address will reply with their router advertisement. And so, as I said, it gives you your network number and its prefix length, and the host will figure it itself out. And so from there, it will actually then send out what's called a DAD message, or duplicate address detection, on a neighbor solicitation packet. And so it will then say, hey, I've picked this address, is anyone else using it? So as long as no one else is using it, it's all set, ready to roll. Now, basically, that router advertisement can actually have three possible sort of setups. So there is the default option that once you've got IPv6 running, it will just say, you know, what we've spoken about up until now is, you know, here's your network number and here's your prefix length, and that's all. And that's great. And then there's also an option where you say, look, here's your network number and prefix length, but also send a DHCP request because you'll need extra information. And so the host will already know its IP address, but then it can figure out things like DNS server and other such things like that. And the beauty of that is you can actually have it just one sort of piece of config, and so it could well be consistent for all of your subnets, where you have the same DNS server and whatever other settings you need to make, and that will just need to be done on the server, and that will work absolutely fabulously. Or you can actually get it to go, so that's sort of a hybrid setup where it figures out its own IP address, but it gets extra information from DHCP. Or you can basically run it in the same mode as what IPv4 uses, where it's fully stateful, where it just gives it an IP address. And so in this mode, the router advertisement message actually says, I'm not going to tell you anything, send out a DHCP request, and that's where you'll get your information. Okay, so SLAAC is the default in Cisco routers. Both the M and O flag are set to 0 on the RA, which means basically, I think I did talk about it in the other slide there. You've got M, which says, do we have a managed network, or do we use the other configuration? And so basically managed, of course, is that. Other information is that, basically. And so by default, they're both set to off, and so you get a router solicitation message, and it's answered by a router advertisement, and done. So there's no more information that's going to be available. And so you can have the stateless DHCP option, and so with that, you need to change the message, and so with that, the client uses the RA message for addressing, but it gets additional parameters from a DHCP server, as I said. So the O flag is set to 1, which says other information. The M flag is left to 0. And so basically you go IPv6, neighbor discovery, other config flag is the way you set that. And so basically the router solicitation and the router advertisement basically are the same, except it also says get some other information as well. And so then the host will do a DHCP request, and away it'll roll. And of course the full DHCP option is neighbor discovery managed config flag. And so you send out your router solicitation that says, I'm not going to give you the information, you've got to use DHCP. So that's what will happen. Okay. So how does the actual DHCP work? And so you got router solicitation and router advertisement. Of course, that happens first always anyway. Just depends on what kind of message comes back. That's the only major difference. And then, of course, we don't do broadcasts. We do a solicit. Now, basically, we don't use the same port numbers. We use 546 and 547 on UDP. And we also, of course, need to use a multicast address. And so it's FFO2 : 1 : 2 is the destination. And so the DHCP, so that's where the solicit message goes. And then DHCP responds with an advertise. We've got solicit and advertise. That seems to be the pairing these days with IPv6. And so basically, if it's a stateless DHCP, it generates its own address, the client, and then sends out the information request, and the server requesting only configuration parameters. Or stateful, it sends out the request message to the server, and of course it will get all of its information, including addressing. Okay, so how do we configure this on a Cisco router? Now we're going to do it stateless to start with. And so IPv6 unicast routing, and then we can actually create an IPv6 DHCP pool. IPv6 stateless is just the name that we're giving it. And so here we can give it a DNS server address and also a domain name. And that's pretty much the only information that we'll need in the DHCP server. Of course, we do need to configure the interface to behave properly as well. And so, of course, we need to give it an IPv6 address. And then you say that we're going to use the DHCP server IPv6 stateless, which relates back to the name there. And of course, we need to put in there for the neighbor discovery other config flag. And so we're saying the router advertisement will say, here's your network number and prefix length, ask for more information. And so it will then send out that solicit message, and then this DHCP server will reply with these bits of information. And so you of course can make a router a DHCP v6 client as well. And so it's IPv6 enable and IPv6 address autoconfig. So there's show IPv6 DHCP pool. There's show running config, of course, will have the information in it. Show IPv6 interface and debug IPv6 DHCP detail will, of course, show you messages as it happens. Of course, that's what debug does. So that was Stateless, where we had the just extra information, that stateless pool. Now we're going to do stateful. And so again, of course, we need to turn on IPv6 unicast routing. We need to create a pool with a pool name. So here we're doing IPv6 stateful. We need to, of course, supply the address prefix. And we're giving it a lifetime of infinite. So we've got a lot of addresses, I suppose. DNS server name, domain name, and that's all you need to do. And so, of course, for the interface itself, it needs to have an IP address from that pool. It needs to be told that it's using this DHCP server for that subnet as well. And, of course, we need to change the neighbor discovery message or the RA, router advertisement message, to be managed. So we've got using full DHCP. And so, yeah, that's basically how you configure it. And so from there, to be a stateful client, it's IPv6 enable, IPv6 DHCP. So again, show IPv6 pool, DHCP binding, of course, because we're mapping addresses to MAC addresses, and show IPv6 interface. Some of that information. So relay agent in IPv6, sadly you don't use helper address. Anyway, it's probably a more sensible name, but of course I've just made a difference. So again, you don't have to have a DHCP server in every subnet with IPv6, and so you can just do IPv6 DHCP relay destination and the IP address of your DHCP server. And that's all you need to do on that interface. And yeah, any DHCP requests from this subnet will be forwarded as a unicast to there. So troubleshooting tasks look very similar, but the only difference really is you might want to verify that the router is responding in the correct way with the right router advertisements. So show IPv6 interface will tell you that, and so with full SLAAC it will just look like this. IPv6 is enabled, and that's it. With stateless, and then with stateful it will again look like this. And so you can see the line host uses stateless auto configuration for addresses. Hosts use DHCP to obtain other configuration. And here it says hosts use DHCP to obtain routable addresses. Okay, so debugging, of course, debug IPv6 DHCP detail will show you events as they happen. And of course, with detail, of course, it's going to give you a lot of information. So you can see that there's a solicit message, and so it tells you what pool it's using and tells you what binding it's created. Okay, so that's the end of the chapter, and so we've looked at how to implement DHCP on both IPv4 and IPv6, so you can work across multiple LANs in a small to medium business. There's the logo. So have a nice day, and I'll see you again later.